Alright, so let's talk about the addition rule. Yesterday we covered the multiplication rule. That's when we had probabilities. When we were looking at the probability of two events happening in sequence. Okay? Now we're looking at mutually exclusive events, whether they are or are not mutually exclusive. Okay? This is indicated by the key phrase or. This event or this one will happen. Okay, so we're not looking at in sequence, but now we're kind of looking at the same time. Mutually exclusive events are when event A and B, or any number of events, cannot occur at the same time, meaning that they have no outcomes in common. Okay? If they are mutually exclusive, they have no outcomes in common. They cannot happen at the same time. If they have outcomes in common, we say that they are not mutually exclusive. Okay? So the sample spaces that are drawn give an example of mutually exclusive versus not mutually exclusive. We have two different events with two separate sets of outcome, and there's no overlap. They are mutually exclusive events. Versus when we have two outcomes, two sets of outcomes, but there is a set of overlap where some of the outcomes are in common, and those are not mutually exclusive events. And we need to make sure that we can identify whether they're mutually exclusive or not, so that when we apply the addition rule, we're not having too many outcomes within our probability. We're not doubling up on some. So, we want to take a look and just kind of think about, are there any outcomes in common? If I have event A, I'm rolling a 3, and event B is rolling a 4. Is there any way for both of those events to happen at the same time when I roll one die? No. It either lands on one or the other, or neither, but it cannot land on both. So these are mutually exclusive events. If we look at the sample space, and event A is we roll a 3, event B is we roll a 4, and then everything else is a 1, a 2, a 5, or a 6. There's no overlap. So we can roll a 3, a 4, or something else, but we can't roll more than one thing at a time. Okay? Event A, randomly selecting a male student and randomly selecting a nursing major. Can those two things happen at the same time when I select one student? Yes. Yeah. You can have a male nursing student. All right? So they are not mutually exclusive. Not mutually exclusive. And again, if we look at the sample space, we can have the list of male students, and we'll have the list of nursing students, and there will be some overlap where there are male nursing students. Randomly selecting a blood donor with type O blood and randomly selecting a female blood donor. Exclusive or not mutually exclusive? Not mutually exclusive. Same thing. Not mutually exclusive because females can have type O blood. So once we've established whether they're mutually exclusive or not, then we can go into the addition rule, which says that the probability of event A or B will occur, and again, that keyword is or. Multiplication rule we use with the word and. Addition rule we're using with the word or. The probability of event A or B occurring is going to be the sum of the individual probabilities minus the probability that both will occur. That's that overlap. So we can find the probability of A and the probability of B, we can add them together. But if there are any outcomes where both of those events are true, because we have that overlap and they're not mutually exclusive, then we need to subtract those extra probabilities so that we're not counting them twice. If they are mutually exclusive events, we don't need that last part because we know there's not going to be any overlap. And so we can just add the probability of A and B. And again, we can extend this to any number of mutually exclusive events. If I have 3, 4, 5, or 6 events, we can just add on addition and subtraction as we need. So we select a card from a standard deck. We want to find the probability that the card is a 4 or an ace. The probability that it is a 4 or an ace. Is that mutually exclusive or not mutually exclusive?
Not mutually exclusive. Because it says or, not and.
Or it could be either one. So that's when we have to look at, is it mutually exclusive or not?
Not mutually exclusive.
Why?
Because
So can they happen at the same time?
no.
That means it's mutually exclusive.
Well, it says or.
It's getting, you draw a card, and the event is, it's either a 4 or it's an ace. That's the event. You get a 4 or an ace. Not that we get both, it's that we get one of the two.
Yeah, that's awesome.
Yes, but I can't draw a card that is a 4 and an ace, so they're mutually exclusive events. There's no overlap in the two outcomes. And so because they are mutually exclusive, we don't have to worry about the overlap part, and we can just add the probability of the two events. And so we'll take the probability of getting a 4, and we'll add it to the probability of getting an ace. What's the probability of drawing a 4 from a deck of cards?
1 out of 50. 4 out of 52.
4 out of 52. What's the probability of drawing an ace? 4 out of 52. So what's the probability of drawing a 4 or an ace? 8 out of 52. Okay? And we can reduce our fraction. 2 out of 13, about 15%. Okay? You roll a die. Find the probability of rolling either a number less than 3 or rolling an odd number. Probability of less than 3 or an odd number. So this was mutually exclusive. Is this mutually exclusive or not mutually exclusive? Not mutually exclusive. What outcome is both of those things? Less than 3 and odd. A 1. Okay? So because we have an outcome that satisfies both parts, both events, then we need to make sure that we're applying the full addition rule where we subtract the probability of A and B happening. And so we're going to find the probability of getting less than a 3, and we're going to add it to the probability of getting an odd number, and we're going to subtract the probability of getting a 3 and an odd number. All right, so what's the probability of getting a number less than 3? 2 out of 6. What's the probability of getting an odd number? How many odd numbers on a 6-sided die? 3 odd numbers. All right, and what's the probability of getting a number that is odd and less than 3? 1 out of 6. So there are 2 numbers that are less than 3. There are 3 numbers that are odd, and there's 1 number that is both. So we need to add and then subtract. 2 plus 3 minus 1 gives me 4, 6. So we have a 2/3 probability of rolling a number less than 3 or an odd number. Frequency distribution shows volume of sales, the number of months in which a sales representative reached each sales level in the past 3 years using the sales pattern. We won't find the probability that a sales representative will sell between $75,000 and $124,999 next month. Are those events exclusive or not mutually exclusive? They are.
If it has anybody chance.
We have these 2 events. Is there any overlap in those events?
Yes.
You know what the word overlap means?
No.
Roll Tide.
Well, no one else is saying anything, so I might as well say stuff. No.
There's no overlap in those events, so we have mutually exclusive. So we just, if we want the probability of getting between 75,000 and 124,999, we need to add, we'll don't feel like running the whole thing, so I'm going to call those events A and B. We're going to add the probability of event A to the probability of event B. Since there's no overlap, we don't need to subtract the probability of A and B because it's not going to happen. What is the probability of event A? 7 out of
36.
And the probability of event B?
9 out of 37.
So what's the probability of both things happening?
16.
16 out of 36.
Yes, I know.
All right. We've got a relative frequency table. Same idea. So we've got their blood types, OAB and AB, as well as whether they are Rh positive or Rh negative. The number of donors who gave blood types shown. Find the probability that the donor has type O blood or type A blood. Mutually exclusive or not mutually exclusive?
No.
Mutually exclusive. They cannot happen at the same time. You cannot be both type O and type A.
You'll die. That's just not a thing.
Well, it depends. So you can't be both, and so we don't have to worry about overlap. So we can just add the two probabilities together. So the probability of being type O blood. The probability of being type O blood.
That would have to be
184 over 409. 184 over 409. The probability of being type A blood. 4 over 409. And so the probability of either thing happening is 48 over 409. The probability that a donor has type B blood or is Rh negative. They're not mutually exclusive. You could be both. So we'll need the probability of being type B plus the probability of being Rh negative minus the probability of being type B and Rh negative. So we look at the probability of being type B is what? 45 over 409.
45? Oh, yes.
Probability of being Rh negative. 65 over 409. Oh, I have equals on there. 65 over 409. Minus the probability of being both B and Rh negative. 8 over 409. All right, so that combined probability is 102 over 409.
102. Nice.
So we've got a nice summary here. All of our different probabilities. So classical and empirical. Classical is every outcome is equally likely. Empirical is based off of observed data. To find the probability for classical, we divide the number of outcomes in an event divided by the number of outcomes in the sample space. Empirical is the same idea, but it's done with frequency that an event happened divided by the number of trials that were taken. Range of probabilities, it has to be between 0 and 1 inclusive. Complementary events always add up to 1. So the probability of something happening and the probability of it not happening have to add up to 1. Our multiplication rule is looked at when we're looking for finding the probability of two events occurring in sequence. We're using that word and. So I want this thing to happen and this thing to happen. Addition rule is used when we're finding probability of at least one of two events happening. So the probability of this or the other taking place, we use the addition or the multiplication rule. For multiplication, making sure we're identifying whether they're dependent or independent events. And then for the probability of using addition rule, we have to identify whether or not it is mutually exclusive or not mutually exclusive. If they're not mutually exclusive, we need to make sure that we are subtracting the probability that they happen together. So we can combine different processes with complements and with addition rule, multiplication rule to find some more complex probabilities. So if we're looking at trying to find the probability that a random selected draft pick is not a running back or a wide receiver, okay? Probability event A is a running back. So we have the complement being not a running back. And probability of event B being a wide receiver. So we have the complement being not a wide receiver. So we want to find the probability that they're not one or the other. So are we going to use addition rule or are we going to use multiplication rule?
Addition rule.
Are they mutually exclusive or not mutually exclusive?
Not mutually.
And you are really struggling with that mutually exclusive thing. Can you be both?
No.
Mutually exclusive. If you cannot be both mutually exclusive, think back to this chart right up here. Right up here, okay? You can't be both mutually exclusive. If you can be both, not mutually exclusive. And I'll give you some credit. It is technically like a double negative, so it's a little weird. But that's what you got to kind of focus on. If it can't happen together, they are mutually exclusive. So we're going to do our probability rule. So what we can do is find the probability of event A or B and then just find the complement. Okay, because it's easier to find the probability of event A that they are a running back and the probability B that they are a wide receiver. And then we can find the complement of that. So we're going to do 1 minus the probability of A or B. Probability of event A or the probability of event B. So what is the probability of event A? Out of 255. And what's the probability of event B? 37 out of 255. So we want to add those two probabilities first to find the probability that they are a wide receiver or a running back, and then to figure out the probability of them not being a wide receiver or a running back, we find that complement. So we're going to have 1 minus 53 over 255.
Why are we minusing that by 1?
This is the probability that they are a running back or a wide receiver. We want the probability that they are not a running back or a wide receiver. So we need the complement. So 53 out of 255 is the probability that we pick a wide receiver or a running back.
So you subtract just that number by 255.
Because we're trying to find the complement.
Why is there 1?
The probability of an event happening minus the probability of it not happening has to add up to 1. So we're just finding the complement of 1 minus the probability that it happens. So 255 minus 53. And we get the probability that they're not a wide receiver or a running back. So that 2 of 2. There's our probability.